Hi guys, this is Mr. Holly. We're going to be looking at how to discover the mathematical constant of pi today. I have Roxana and Jason with me, and they are going to kind of work out some of the like the experiments that we would be doing in class. So you guys will kind of get to experiment with them. And I'm going to set this up so that you can experiment at home as well, okay? What we've done is we've collected as many circle objects as we could just around the classroom. I've got some lids, I've got some other some products, I've got some like a pencil eraser, we've got some different stuff, bottle cap, a coin. So we're finding as many circle objects as we can, and we are going to be measuring the circumference and the diameter of these objects. Those are two vocabulary terms that should be new to you, so the first thing you need to learn today are the two vocabulary terms circumference and diameter. First, circumference is the distance around the perimeter or the outside of the circle. So if you were to measure all the way around a circle, we call that value, that distance, we call that the circumference. And then if you were to measure directly across a circle, like right through the center, if you were to draw a chord or a line right through the center of a circle, that measurement would be called the diameter. So those are the two measurements that we're looking at today, the diameter and the circumference of a circle, okay? I will film Roxana and Jason as they measure the circumference and diameter of some circles and show you guys how you could do this same experiment at home. All right, so Jason and Roxana are modeling how we're gonna do the measurements on these circle objects. As you can see, they're taking a piece of yarn or string, and what we're doing is just starting with, put the end of it down on the circle somewhere and then wrap the string around until you reach and find the distance all the way around. Then you're gonna take that string and put it down on a ruler. You'll be able to measure the distance around the circle. So what did you come up with there, Jason?
22.
22. What are you measuring in? Centimeters or inches?
Centimeters.
Centimeters. And it's important that we keep the same unit. So we're gonna measure it in centimeters. And then as you can see, Jason recorded his number in his chart. That chart is on page 64 in your notebook. So you can find objects all around your house. Do this right here. You're just measuring around them and then across the middle, and you're getting the number of centimeters around and then the number of centimeters across, okay? So Jason, you found one that was 22 around and 7 across. And Roxana, what was the circumference was?
22 and a half.
22 and a half. And what was the distance across?
Haven't done that right now.
Okay, so now Roxana's measuring across. And you want this to go right through the middle of the circle, kind of estimate where that's at. And then
And 7 centimeters.
about 7 centimeters. Okay, good.
So the same thing.
Hers was about 22 and a half and 7. Jason's was about 22 and 7. So basically they've got about the same value there, and they're recording those in their notebook. So you guys do that at home. Find some circular objects, measure the circumference and the diameter. All right, so at this point, Jason and Roxana have recorded about 8 different items. They've measured circumference and diameter on each, and they have their table filled out. We can look here at their values. The next instructions that they're gonna follow are to go through and play around with some different operations. So we're gonna just look for patterns. What happens if we add circumference and diameter? What happens if we find the difference between circumference and diameter? What happens if we multiply them? What happens if we divide them? Like, we're just gonna look at just kind of experiment with those two measurements and see if we can find any patterns that emerge. All right, so Roxana and Jason have their table complete. They have done all of the different operations. We just had a conversation. We're trying to see, do we see any patterns now? When I add the numbers together, is there any pattern that I'm seeing? When I subtract the numbers, is there any pattern that I'm seeing? If I multiply them or divide them, do I see any pattern? Are my answers all over the place? Am I getting big numbers, small numbers, similar numbers? Jason did point out that when we divide, we see some decimals. So we haven't really made a conclusion yet about the relationship between circumference and diameter based on just this part of the activity. So what I'm gonna have Jason and Roxana do, and what I'd like you to do at home, is turn the page of your notebook, and there's a graph. I would like you to graph each of the objects that you measured. So you're going to graph circumference as your y variable and diameter as your x variable, and you're gonna graph each of the objects that you measured to see what it would look like on a graph. All right, so Roxana and Jason have finished their graphs. They have plotted each of their points on the graph. And Roxana, what was the observation that you were able to tell me about your graph? Kind of looks like what?
A straight line.
Yeah, so we just went ahead and we sketched in a straight line, just like a trend line. It didn't hit every point, but it kind of went through all of her points, and we saw that there was just a trend, that it was essentially a straight line. So I asked the question, if we have a graph that has a straight line, and that straight line is going through 0, 0, what do we know about the relationship between circumference and diameter?
It's proportional.
It's proportional, exactly. So I asked the same, so we said, how could I test? How do we test to see if something's proportional if we don't have a graph? Like, what would we do? And Jason, that's when you told me we would do what?
Y over x equals k, and k is the constant.
We would do y over x equals k, and k would be the constant. So in this scenario, our y variable is our...
When we divided the diameter and the circumference.
Exactly. And tell me the y and the x. The y was circumference, and the x was?
Diameter.
Exactly. So whenever we divide circumference divided by diameter, we should see a constant emerge.
3.1, but we didn't really measure correctly. Well, we measured correctly, kind of, because...
We kind of estimated when it was like past it.
Okay, so because you estimated a little bit, you ended up all with numbers that were all close to what?
3.
All close to 3, right? It wasn't precise, it wasn't exact, because we don't have exact measuring tools, right? You didn't measure down to the millimeter, decimeter, all that kind of stuff. Most of the time you just rounded to the nearest centimeter, okay? So it's not exactly perfect, but it got somewhere between 3 and 4 was the constant rate that we came up with. That constant is pi, big reveal. The relationship between circumference and diameter is pi. That is the constant relationship. So the equation that we're going to develop, if we go back to our understanding of proportional relationships, it's always y is equal to kx. Well, that means that y, which is our circumference, is always going to be equal to pi times diameter. And that's the big takeaway. We're going to study circles, and that's the equation that you have to be able to use for this. Pi will always be our constant that will relate the circumference and the diameter to one another.